Hello everyone. So today we are starting next chapter of the module 2, which is chapter 2.2, which is related to MCB, which is miniature circuit breaker, DB distribution board, RCD, which is means residual current devices. Okay. So let us just understand this all these concepts one by one. Okay. So the MCB, which is miniature circuit breaker. Okay, miniature generally only given just for the fact that it is due to its compact design and it is intended to use for smaller currents like for the household or residential purposes. So MCB is basically a circuit breaker. Circuit breaker means which breaks the circuit. Okay, if this is my mains, okay, this is my some load, so this is my MCB. Okay, this is my MCB. This is I am assuming 120 volt line and neutral. So if any fault happens here, okay, to the ground, a large fault current will be flow. So this MCB will detect this and trip this circuit, so that it will be, if before it will be like this, after breaking the circuit it will open it. So it is basically safeguarding the other the other part of my circuit, the healthy part of it. So MCB works when there is an overload, okay, or there is a any short circuit. Okay, and sometimes it can be used as a switch, okay, to manually turn on and turn off any device, any large current carrying device, mainly for ACs or heaters. This can be used as a switch also. Now the advantage, earlier in the conventional or in earlier days, what were the safety device? The safety device was fuse. But what happens with the fuse is it it cannot be reused. If we need to, always you need to replace it. Okay, whenever there's a fault or there's any, so it will damage itself. Okay, it will it will break the circuit by damaging itself, so you need to replace it. But in case of MCB, the mechanism is such that you do not need to replace the MCBs again and again. If there's an overload or short circuit, it will trip automatically. Okay, and you can reset it also after clearing the fault. Now the question arises, why do we need protection from the overload and short circuit? The reason for protection for overload is, between in this circuit also, we can see there is, these are the wires. Okay, these are the wires and cables from the mains to overload. Now if load is overloaded, means its rating was 10 ampere, but due to some reason it is consuming 15 ampere. Now what will happen gradually, as we already seen, that the drop or the losses in the cable or in the wire are directly proportional to I square, means the square of the my current carrying. If my current is increasing, these losses will increase and will lead to heat, and this heat will lead to the dissipation, will dissipate as a meltdown of my insulating layer of my wire or cable. Okay, so then it may lead to fire hazard, or it may lead to further more faults. This is why we need to protect it from overload. Now short circuit is again a phenomena in which my one of the wire, like live wire, is connected to ground. In that case, as there is no resistance, initially this load was there, but as my main line is grounded, so there is no resistance. So due to and we already know by the Ohm's law, V is equal to IR and I is equal to V by R. Okay, if this R is very negligible, it will again lead to a very high current. As my voltage is fixed, but this R earlier was have some value due to this connection of this load, but now what happened, this R become very negligible due to fault. So it will lead to very high current, and this high current, a very high current, will again lead to fire hazard, faults or damaging my other system. Okay, because every equipment is designed for a particular current rating. If a high current is drawn, it will lead to damages the internal parts. So this is why my circuit or my equipment or my system need to be protected from the overload and short circuit. And this is where the MCBs work. The next part of this chapter is how we select and size the MCB. So from the IC standard, the general household voltage is 230 volt single phase. From the NEC point of view, it is 120 or 240 split phase system is used. In case of IC, the MCB rating should be such that it should be more than the load current and it should be less than the cable or wire ampacity rating. Okay, the same thing is used in NEC, but in case of IEC, one more common practice is used. Common, it may be used or may not be used. Like in case of continuous load for more than 3 hours, uh, my size of MCB is such that it should be 125% of load. What does that mean? That mean is if my load is taking a current of 10 ampere continuously, it's rated for 10 ampere continuous current, then my MCB should be sized for 12.5 ampere. Okay, so in the market, the general current rating available for MCBs are either 10 ampere or 15 or 16 ampere. So we will be selecting which type of which MCB, 15 or 16 ampere. 15 is in the NEC, 16 is in the IC standard. So we'll be using this MCB for 10 ampere of continuous load. Okay, and in the NEC there is a mandatory rule that you need to select it. Okay, but in IC there is no exact rule anywhere written, but we generally take this. Okay, now again one more detail we need to consider is this is just for information that we generally use B type of curve for lighting and residential loads. Okay, and C type of curve for motor and AC pump in case of MCB. This B and C curve are basically the tripping curves. Okay, because every device have this time and current characteristic, like for how much time, how much current it will take to trip. There are different curves like this. Okay, like if my current is increasing, my this tripping time will decrease. So this is how this BC and the other curves are are there, just to know that how fast it is in the tripping process. So for the critical loads such as motors, ACs, pumps, people for the for the valuable loads means the we generally use C curve type, and for residential loads we generally use B curve type. So for the detail of it, we'll be looking in our other advanced courses. But for now, sake of continuity, I have explained it here. So for for our residential purposes, all the MCBs will be of same B curve or C curve, because in the residential there is no much, we are not concerned about the tripping time, because it is more of importance in case of the industries or commercial buildings where we need to coordinate also. Okay, this is a new term. You do not need to worry what the coordination is. This is not required in residential purposes, but for more detailing and more info of this concept, we'll be looking at in our more advanced courses. So this is how my MCB is selected and sizes. Now let's move to our next topic of this chapter is distribution board. So distribution board in any house you have seen in your house also. The main purpose of distribution house is to take the supply from mains. Okay, to take the supply from mains and having some protection arrangement, then distribute into other parts of load. Okay, these are different part of loads. This is my dB. So dB is basically a middle buffer for distributing my different loads or distributing the power. So this is on dB. These are the main my main wires coming from the mains. This is my main MCB. I can say these are different MCBs for different circuits. Okay, different circuits of the different houses. This is my earthing bar. This is my neutral link. Okay, we'll be looking about dB in detail, like how this circuit segregation. So segregation work, how to select and size the different components of dB. We'll be looking at it in a different part. Just for now, the introduction point of view, dB is nothing but an equipment and device which is used to distribute the power to my entire house. The next thing is the RCDs, which are residual current devices. So RCDs are nothing but are the sensitive devices, sensitive protected devices, which detect the leakage current while comparing the phase and neutral current all the time. In case of IEC, they are called RCCB, which are residual current circuit breakers, which sensitivity here starts from 10 milliampere. And in case of NEC, these are called GFCI, means ground fault circuit interrupted, with sensitivity of 4 to 6 milliamps. Now what does this sensitivity means? So this sensitivity means nothing but the difference in my phase and neutral current. If it is there, if this much of my difference is there, they will detect it. So the lesser the current, more it will be more accurately, it will detect the leakage current. Okay, but in case of our houses, we uses a standard 30 milliamp 30 milliamp sensitivity RCD, residual current device. The reason is 30 milliampere is that point where below it won't cause any severe damage to the human, but above it will cause severe damage, or it will cause hazardous effects on the health and the body. This is why 30 milliampere generally we take. Now the basic principle of RCD is nothing but this is the live wire, this is my neutral wire. So in a healthy case, what will happen if this is my load, this power will go and it will come back. So this is how my circuit is completed. But in case of any leakage, what will happen? Where I can explain it, 1 second. I am taking this space. So what will happen? This load, the general principle what says, if this is my IL is coming, this IN should come back. So in healthy case, IL is equal to IN. But if there is any leakage from this this equipment or this device, if I am assuming it as IR, so if this is my IL, then it will be IN dash. So what will happen now? The current will be IL will be equal to IR, which is the residual current or the leakage current, plus IN dash. So this IR, okay, IR which is equal to IL minus IR dash now will be act as an actuating current. Okay, now what it will be act as an actuating current, and it will trip that particular circuit or trip that particular device until that leakage is corrected, or until that leakage is handled. Okay, so this IR, which is the residual or the leakage current, will act for protection of any person or any device for any faults. The next part of this chapter 2 is understanding the difference between IEC and NEC, because as we are doing this course parallelly, so we should know what are the different main differences. So we have seen there are few differences in terms of RCDs. We have seen in wherever it will be applicable, I will be putting it, I will be explaining it like how in IEC it is work and how in NEC it is work. But the one more difference is in their color coding. So for the for in case of wiring, the IEC color code says the live or the line wire should be brown, the neutral will be blue, and the earth or the ground wire will be yellow green. Okay, in case of IC color code, the line wire should be black. Okay, and the neutral will be white, and my earth ground will be green. Okay, so this we can understand in this two diagram also. This is for the IC and this is for NEC. In the IC you can see this is my brown wire, means my live wire. This is my neutral. These two are coming in this MCBs. This neutral will be going to connect, and this neutral link, this live wire will be connected between my MCB, between one terminal of MCB and other will be two loads. Now if I want to supply to the load, this is load, so this load one terminal will be connected from this live and other will be connected from this neutral. Okay, from this neutral link. Now in case of some loads, there is a requirement of 3 pin, as we have seen in the 3 pin socket. If this is live, this is neutral, and this is the earth, so this live will be connected from this L, this neutral will be from this neutral link, and this earth will be from this earthing terminal. Okay, the earth link, a new wire will be connected to this earth. In case of NEC standard, we have two live wires, L1 and L2, and neutral. These are again based on this color coding I have shown here. So these are two points for the live one and live 2. Now for few circuits only L1 required, so my MCB will be single pole. Okay, SP single pole means it will only disconnect one of one of a circuit. But for the loads where there are two requirement of two lives, okay, for the 20 ampere circuit in case of NEC especially, then I will be using a DP, means a double pole MCB, to break both the live in okay, in case of any maintenance or in case of any fault. So it is same as this our IEC we have seen. So the circuit connection, about the circuit connection we will be looking later in detail also. So for just for for sake of clarity, that the main differences I have shown here. Now in case of IC, in NEC, a question and I, why there are two live wires in case of NEC based? It is because for some light loads only a 120 volt is sufficient, but for few higher capacity or higher power power consuming loads. 2 L1 and L2 means we need to provide a higher voltage. Okay, and these are in phase opposition. So the combination of these two will give me 240 volts. Okay, now if I have increased the voltage, as we know, for the same power rating my current will decrease. If this is constant, if my voltage is increased, then my current requirement, current zone will be decreased. So the 240 volt is provided for the higher loads like ACs or heaters, such that my current zone is decreased, so that my losses and other other designing parameters reduces. So this is why in the NEC the two live wires are used. So this was it about in the chapter 2.2 of my module 2. Thank you everyone. Thank you for your time and attention. In the next chapter of the module 2, we'll be looking at the grounding and appliance earthing. These two things are very important for the safety point of view, for the safety of the system and safety of our household and the safety of the person uh, or any life per se. So these two are very important. So we'll be seeing about them in detail in the later chapters. Thank you everyone.